All right, so this video is going to start the circular motion unit. So we're going to start on page 2, and this is going to go through page 5. So circular motion, so we're going to talk about uniform circular motion, or UCM, refers to an object moving in a circle or part of a circle at a constant speed. That is what that uniform means. It basically means you're not changing. So if the object is moving at a constant speed, its speed can be calculated by distance over time. So this equation, speed equals distance over time, was one of the first ones we talked about. But now we're talking about a circle. Okay, so when we talk about distance, if we use once around the circle, the distance will be the circumference of the circle. Okay, so we're still basically doing distance over time, but now we're actually using the distance in a circle. So d equals 2 pi r. So remember, to find the circumference of a circle, it's 2 times pi times the radius. And then the time to go once around the circle is called the period. Okay, so that is kind of a newer term. Okay, so the period is the time it takes to go around one time. So for some reason, that term kind of proves to be confusing throughout this unit. So just make sure you know that it is the time to go around once. And that is capitalized by uppercase T. So there's a difference between lowercase t time and uppercase T. Lowercase t just means time in general. Okay, uppercase T means that is the time it takes for one rotation in a circle. So it is specific to circular motion. So make sure you know the difference between those two, because we're going to see some examples here in a bit where that can kind of get a little confusing if you don't know which one to use. So that brings us to our equation. So remember, velocity is distance over time, or in this case, circumference divided by the period. So there is our first equation right there. So V equals 2 pi r over t. So your velocity is in meters per second, which means your radius has to be in meters. So remember, if you are in centimeters, you need to get to meters. So 1 meter equals 100 centimeters. And then if you're in kilometers, so 1 kilometer, you need to get to meters, which is 1,000 meters. Okay, and your time is going to be in seconds. Now, in uniform circular motion, the magnitude of the velocity stays constant, but the direction is constantly changing. So the direction of the velocity at any given point is found using a tangent line to the circle at that point, thus called tangential velocity. So remember when we did like a graph where you had like a curved line and you had to find the velocity of that line? Remember what we did is we found that point and we drew like a little tangent line that bumps up next to that point. That's what tangent means. So we're going to do some labeling here in a second. So inertia states that an object wants to stay at a constant velocity, so that's Newton's first law. Constant velocity means at a constant speed in a straight line. An object can change velocity two ways, okay? Or I'm sorry, you can accelerate two ways. One is you can change your velocity, okay, so change your speed, or you can change your direction. Okay, so if we have an object that's moving in uniform circular motion constantly, okay, which is constantly changing its direction. If we're constantly changing our direction, that means we are constantly accelerating. Okay, so that's probably one of the tougher conceptual things for this is you can be spinning something around at a constant speed, okay, but it's constantly accelerating because that object is constantly changing direction. Okay, so just kind of tough to kind of get that in your head, so just make sure you can think about that. So now we're going to talk about centripetal acceleration. So centripetal acceleration is the acceleration of an object in circular motion. Centripetal means center seeking, which means it's always towards the center of the circle. So what we're going to do is we're going to draw a diagram. We're going to figure out where's velocity going, where's acceleration going. So we're going to say this object is moving in a clockwise pattern. Okay, so we're going to have the center of the circle right here, and we'll say that we're spinning an object out here on the end. Okay, so if I want to know which way is velocity going at that point, okay, remember your tangent line bumps up next to this line and then keeps going through. Okay, so your velocity would be this direction. Okay, so just that kind of think about is if you decided to not, or say this was you driving in a circle, and you decided to stop driving in a circle at that point, which way would you go? You're not going to just keep doing this arced pattern here, okay? What you're going to do is you're just going to go straight from where you left. Okay, so kind of think of like old school slingshots, the one where you spin around And if you want to hit a target, that means you would have to let go of that object at that point. So say your target's like right here. Okay, you'd have to let go at that point for it to actually hit that target. Okay, so that is where the velocity is going. Now your acceleration is always towards the center, no matter where you are. Okay, so we can bring things like direction back. So remember your north, south, west, east. So if I asked you which way is acceleration pointing in this instance, you would say acceleration would be south and your velocity would be east. Now if you take that same object, but now that object is here, okay, velocity is now going to be tangent this way. Okay, so that means if you were to stop driving in a circle at that point, that's the way you would go. So there is your velocity, and then now your acceleration is pointed towards the west. It's still pointing towards the center, but now your directions have changed. Your acceleration would be towards the west, and your velocity would be towards the south. Okay, so that's how you would basically label that. Now, if you want to calculate centripetal acceleration, AC can be found by doing V squared over R. Okay, your R still has to be in meters, velocity has to be in meters per second. So don't confuse this with the acceleration that we learned last semester. So last semester we did A equals V over T. That is for linear motion. That is not for circular. Okay, so just be careful with that because we will deal with velocities and we will deal with time. Okay, but that's not how we calculate acceleration in a circular path. Okay, so we're going to do a little bit of examples. So we're going to do a car turns a curve at a speed of 20 meters per second. So there's your velocity. The radius of the curvature of the turn is 100 meters. So there's your radius. What is the centripetal acceleration? So we're looking for AC. So remember, AC equals V squared over R. Okay, so we're going to do 20 squared over our radius, which is 100. So 20 squared is 400 divided by 100, and that gives you 4, and our units is meters per second squared. Okay, next example, a ball on a string swings in a horizontal circle, the radius is 2.0 meters. There's your radius. If the centripetal acceleration is 15 meters per second squared, there's your acceleration. What is the speed of the ball? That means we're looking for velocity. So we're going to plug in. So AC equals V squared over R. We don't know V, so I'm going to leave it as V squared. And your radius is 2. So multiply both sides by 2. You get V2 equal, or V squared equals 30. So don't forget that squared. So now we need to square root both sides. So square root of 30 is going to be 5.48 meters per second. And there's your answer. Now, kind of going back into period, remember we talked about that, is period is the time needed to go once around the circle. So again, these things are bolded and underlined for a reason, so make sure you know them. And it's characterized by the uppercase T. Now, frequency we talked a little bit about in chemistry last year. It was the number of waves in a second. Well, in this case, we're just talking about rotations per second. So frequency is the number of times something can go around in a unit of time. In this case, usually we're dealing with how many times can it go around in 1 second. Okay, so there's a difference between those two, so just make sure you know the difference. Now, they are reciprocals of each other, which means they're inverse or opposite. So if F frequency equals 1 over period, or 1 over T, therefore T equals 1 over frequency. Okay, now there's a couple other ways that we can find period and frequency. And I've used this example in class, is if I have someone running like a 4-minute mile, which I know is extremely fast, and I asked you, how long did it take you to do 1 lap? Okay, what you would do is, there's 4 laps to a mile, so you would do is you'd take your time, 4 minutes divided by 4 laps, and therefore it takes 1 minute per lap. So if you want to find the time it takes to go around one time, just take the time, the total time, and divide it by the revolutions, or the number of times it went round and round. Okay, your frequency is going to be the opposite. It's the number of revolutions divided by your time. Okay, which we'll do some of that here in a sec. The two can be distinguished by their units. So period is measured in time, so therefore it's going to be in seconds. Frequency is the number of revolutions per second, so how many times it can go around and round in 1 second. And the unit for frequency is called hertz. That's what that Hz is. That's just the abbreviation for hertz. So moving on to the last page. What is the centripetal acceleration of a stone being whirled in a circle at the end of a 1.5 meter string if it makes 5 revolutions every 4 seconds? So we're looking for AC. That's your question mark. Okay, I gave you radius. Okay, now you don't have to ever really mess with these distances. The only time you would ever have to cut anything in half is if I actually said the word diameter. Okay, so if I don't say that, usually anytime you're spinning something around in an object, spinning something around by attached by like a string, a rope, something like that, whatever the length of that is the radius. Okay, so if you see diameter, then you know to cut it in half, which we'll worry about that later. And it makes five revolutions every 4 seconds. So my whole goal is to get here. AC equals V squared over R. I do have radius. I don't have velocity though. Okay, so that means I got to go back and find it. I need it. So velocity equals 2 pi R over T. Okay, I still have radius, but I actually don't have the time it takes to go around one time. Okay, I don't have that capital T. But remember we talked about that is if you take your total time, which is 4 seconds, and divide it by your revolutions, which is 5, 4 divided by 5 gives you 0.8 seconds. Now, this is where I'm going to come back to that point where there's a difference between lowercase t and uppercase t. Okay, if you just read that 4 seconds right there and say, well, that's the time it takes for one rotation, you'd be wrong. Okay, now that is a time, but that's just general time. Okay, uppercase T, that period T, is the time it takes for one revolution. So please make sure you don't use that 4 seconds in your actually velocity equation. You're going to use that 4 seconds, but you're going to use it here to convert that to your period. So it actually takes 0.8 seconds to go around. So velocity equals 2 pi times my radius, which is 1.5, over T, okay, which is 0.8. Okay, so multiply the top, divide by the bottom, and you get 11.78 meters per second. Now what we're going to do is we're going to take that velocity, we're going to bring it over here to V squared over R. So I'm going to take that 11.78 squared over R, and that's 1.5. And we get 92.51 meters per second squared. And there's your final answer there. Now, a ceiling fan with a radius of 80 centimeters, okay, so we have our radius, is spinning with a frequency of 10 hertz. We have frequency. Calculate the centripetal acceleration of the outer edge of the blade. So we are looking for AC. Now, first, can't have radius in centimeters, so 80 divided by 100 should fix that, so that's 0.8 meters. Now, if you notice that, we usually use T. Okay, frequency doesn't really do you any good. If you look at your equations, F isn't in there. Okay, we usually need uppercase T. So remember, period is 1 over frequency. So 1 over 10 means it takes 0.1 seconds for one rotation. Now, we're trying to get to AC. So AC equals V squared over R. I don't have V, so I need to find it. So we're going to do the same thing we did in the problem before. So V equals 2 pi R over T. So 2 pi times my radius is 0.8 over time, which is 0.1. Okay, and that's going to give me a velocity of 50.27 meters per second. Now I can bring that over here to my AC. So AC equals V squared over R, so 50.27 squared over my radius, which is 0.8. Okay, so my acceleration is going to be 3,158.84 meters per second squared. Okay, so now it is okay to get bigger answers. We're talking about a fan, a small fan that's moving very quickly. Okay, so it is covering a lot of ground. It spins around 10 times in a second. Okay, so you're going to see typically higher numbers when you talk about velocity and acceleration. Now, last problem is Mercury moves in an approximately circular path around the sun at an average distance of 5.8 times 10 to the 10 meters. That is your radius. With a period of 8 times 10 to the 6 seconds, that is your time, your period. Okay, what is the centripetal acceleration? Okay, so AC equals V squared over R. If you can notice, I don't have V, so I know I'm going to have to find it. So V equals 2 pi R over T. So 2 pi times my radius, 5.8, times 10 to the 10. All over my time, 8 times 10 to the 6th. Okay, just make sure you're using your calculator correctly on this one. This is where we see a lot of calculator mistakes. You should get 45,553.09 meters per second. Okay, and again, we're talking about Mercury going around the sun. Okay, so it's actually covering a lot of ground, so it's actually moving very quickly, so that's why you see a big number like that. So don't get scared about the big numbers. Okay, step 2, so that was step 1. Step 2, what we're going to do is we're going to find our AC. So AC equals V squared over R. So we're going to take that V we just found, 45,553, 0.09, and we're going to square it all over our radius, which is 5.8 times 10 to the 10. And that's going to give us an acceleration of 0.036 meters per second squared. And that'll end that one.